This video is going to discuss two-dimensional motion, all about things moving horizontally and vertically at the same time. So we've talked about objects moving with constant acceleration and constant velocity, moving side to side as well as up and down. But what about moving objects that are going side to side and up and down, like things flying through the air, having gravity affect them while moving sideways? That's two-dimensional motion. So that's what we're going to call 2D motion. We need to talk about that. So essentially we can break any two-dimensional motion into two parts. The vertical part, like up and down like a y-axis, and the horizontal part, like an x-axis. The vertical component is simply free fall acceleration, the stuff we just got done talking about. So we can think of the vertical component of two-dimensional motion just as free fall acceleration. It doesn't depend on the horizontal velocity at all. So it doesn't really matter for the vertical part how fast the horizontal velocity is. The fall happens the same way. In other words, like in this picture here, the red ball is dropped while the yellow ball is launched horizontally, and then it falls with it. So they would hit the ground at the same time, even though the yellow ball has more horizontal velocity. In other words, the horizontal velocity of the yellow ball does not impact the time it takes it to fall. So we can use the same acceleration equations we've been using to describe the up and down part of two-dimensional motion. The horizontal component doesn't involve any acceleration. For the most part, all the problems we're going to do are not going to have air resistance. So there's nothing there to slow something down horizontally. Once it's thrown or launched, the object flying through the air won't slow down horizontally. Its velocity will change vertically due to gravity, but that only affects the vertical component, not the horizontal. So we can just use the average constant velocity equation, d equals vt, or v equals d over t, to describe the horizontal motion of two-dimensional motion. Time for a challenge question. So a bullet is fired horizontally from a gun, while at the same time a bullet is dropped from rest from the same height as the gun. Which bullet hits the ground first? If you said the bullet fired from the gun, you would be wrong. Yeah, the bullets from the gun is going very fast horizontally. Gravity doesn't care about horizontal motion, so it acts on both bullets the same, and since they're at the same height, they'll take the same time to hit the ground. The fast-moving bullet moving sideways has no effect on this whatsoever. It would just hit the ground, far away from where the gun was fired. So objects can also be launched at angles instead of just straight up or straight horizontally. So an object that has some velocity v up at some angle theta above the ground actually needs to be broken into two components called the horizontal component and the vertical component of that velocity. The horizontal component is often abbreviated as like vx, meaning like horizontal, and vy, meaning vertical. And the horizontal component is v cosine of theta, so whatever the hypotenuse of this triangle is times cosine of that angle. And the vertical component is v sine theta, so the hypotenuse times sine of theta. All in degrees, not radians. So to recap, we use the acceleration equations to describe the vertical part of two-dimensional motion. It's essentially just free fall. And we use the constant velocity equation for the horizontal part. Objects moving with two-dimensional motion do not accelerate in the horizontal direction and only accelerate vertically due to gravity, assuming there's no air resistance. Thanks for watching.